Ever looked out at the vast ocean and thought about its power? We know it's huge, beautiful, and full of life. But did you know there's something even more incredible happening beneath the surface? A kind of hidden engine driving our entire planet's climate? Today, we're diving deep, literally and figuratively, into the fascinating world of ocean currents. We're going to explore what scientists sometimes call the Great Ocean Conveyor Belt, a massive interconnected system that acts like a giant river flowing within the sea. This invisible river is absolutely crucial for regulating temperatures, distributing heat, and ultimately shaping the weather patterns we experience every single day. Think about it. Why are some places on Earth scorching hot while others are freezing cold? Why do some regions get consistent rainfall while others are deserts? A huge part of the answer lies in these incredible ocean currents. Stick around, because by the end of this video, you'll never look at the ocean the same way again. And hey, before we set sail on this oceanic adventure, make sure you hit that subscribe button and ring the notification bell so you don't miss any of our future explorations of the amazing world around us. So, what exactly are ocean currents? Simply put, they are continuous, directed movements of seawater generated by a variety of forces acting upon the water, including wind, the Earth's rotation, the Coriolis effect, and differences in water density. You've probably heard of surface currents like the Gulf Stream. These are largely driven by prevailing winds. Imagine the wind pushing the water across the surface. That's essentially what's happening. These surface currents are responsible for a significant amount of horizontal heat transfer across the globe. But the river in the sea we're focusing on today is more complex and operates on a much grander scale. This is called thermohaline circulation. Thermo refers to temperature, and haline refers to salinity, the amount of salt in the water. Differences in temperature and salinity create variations in water density. Let's break down these two key factors. First, temperature. When ocean water near the poles gets very cold, it becomes denser and sinks. Think of it like a cold air mass sinking below warmer air. Simultaneously, the formation of sea ice further increases the salinity of the remaining water. When seawater freezes, the salt is largely excluded and left behind in the surrounding liquid water, making it saltier and therefore even denser. Now let's talk about salinity. Evaporation in warmer regions can also increase salinity, making the surface water denser. However, the dominant driver of deep-sea circulation is the cold, salty water sinking in the high latitudes, particularly in the North Atlantic and around Antarctica. This sinking of cold, salty water kicks off a global circulation pattern, the Great Ocean Conveyor Belt. Imagine a giant, slow-moving current that circulates through all the world's oceans. Warm surface water flows from the tropics towards the poles. As it reaches these colder regions, it releases heat into the atmosphere, which is why Western Europe has a much milder climate than other regions at the same latitude. Cools down and becomes denser and sinks. This cold, dense water then flows along the ocean floor towards the equator, eventually warming up and rising again in other parts of the world, completing the cycle. This entire process can take hundreds, even thousands of years for a single parcel of water to complete its journey. So, how does this massive underwater river control our climate? The most significant way is through the distribution of heat. The ocean absorbs a tremendous amount of heat from the sun, especially in the tropical regions. The ocean currents act like a global heat pump, transporting this warm water away from the equator towards the poles and bringing cold water back towards the equator. This redistribution of heat helps to regulate global temperatures and makes many regions of the world more habitable. Think about Western Europe. It's located at a relatively high latitude, yet it enjoys a much milder climate compared to parts of North America at the same latitude. This is largely due to the warm waters of the Gulf Stream, which carries heat across the Atlantic. Ocean currents also play a crucial role in weather patterns. Sea surface temperatures significantly influence the formation and intensity of storms like hurricanes and typhoons. Warmer waters provide more energy for these storms to develop. Furthermore, ocean currents affect rainfall patterns and can contribute to both droughts and floods in different regions. The interaction between ocean temperatures and atmospheric circulation is incredibly complex and a key area of ongoing research. Now here's where things get concerning. Human-induced climate change is starting to have a significant impact on this delicate balance of ocean currents. As global temperatures rise, polar ice caps and glaciers are melting at an accelerated rate, adding large amounts of freshwater to the Arctic and southern oceans. This influx of freshwater can dilute the salty water, making it less dense and potentially slowing down or even disrupting the sinking process that drives the thermohaline circulation. Scientists are also observing changes in ocean temperatures and salinity patterns. A significant slowdown or collapse of the Atlantic Meridional Overturning Circulation, AMOC, which includes the Gulf Stream, is a potential scenario with serious consequences for global climate. This could lead to significant cooling in the North Atlantic region, changes in rainfall patterns across the globe, and even sea level rise along the eastern coast of North America. While a complete shutdown is considered a lower probability in the immediate future, even a significant slowdown could have far-reaching and unpredictable impacts on our climate system. The good news is that it's not too late to take action. Reducing our greenhouse gas emissions is crucial to mitigating the impacts of climate change on our oceans and their currents. This means transitioning to cleaner energy sources like solar and wind power, improving energy efficiency, adopting sustainable transportation options, and protecting and restoring natural carbon sinks like forests and oceans. On an individual level, we can all make choices to reduce our carbon footprint, such as consuming less energy, reducing waste, and supporting sustainable businesses. Every little bit counts. Understanding the vital role of ocean currents in our climate is the first step towards protecting this crucial system. By working together, we can help ensure a more stable and predictable climate for future generations. So there you have it, the incredible story of the river in the sea and how it controls our climate. It's a complex and interconnected system, and understanding its importance is vital in the face of climate change. What did you find most fascinating about ocean currents? Let me know in the comments below. I'd love to hear your thoughts. If you enjoyed this deep dive into the ocean, please give this video a thumbs up and share it with anyone who might be interested. And if you haven't already, don't forget to subscribe for more explorations of the amazing science that shapes our world. Click the bell icon to get notified of our next video. Also, comment what topic would you like for our next content.